So hello guys and welcome. I am Daud from Credo Algo. Today in this video I'll give you a walkthrough with an example code in Google Earth Engine. So let's get started. Now first we will run some code and see actually how it's happening. You don't need to stress about all the function and details in code right now. In future videos I'll discuss about all of them in details. So let me open my Google Earth Engine code editor. In my previous video I have already discussed about how to sign up for Google Earth Engine account. If you haven't checked that video yet, so please do check out that video. So in the left panel in the script tag, you can see there are examples given already in the Google Earth Engine. So from this example, I will take one script and run. Okay. So let me take an example from the image collection, and there is a script called filtered composite. I will just double click on that and the whole script will show in the work area. So here you can see when I'll click on the run button, it will show a layer on the map. This is the layer which is the true color composite of the selected region. This area is near the Colorado and Utah. Now let's go through the code, and I'm just explaining the code overview and how it's working. You don't need to panic about details right now, and I will explain all of this in future videos. Okay. Here it has taken a Landsat 7 images. First here it is defining the region in the map by polygon, defining the pixel position. Here you can see this the defining the region. Now Landsat has many images from the year 1999, so we don't require all of the images in our collection of dataset. So let's see the Landsat image. If I take the collection, copy the collection and open another tab, here if I just type the print command, collection dot size function will give me how many images it contains in the Landsat 7 data model. Okay, so if I run the script, here it will display that how many images right now it has. It's computing the size. Mm, the whole process, it also depends on your internet connection, as I already said in my previous video. So you should make sure that you have a proper internet connection whatever you run the script, because there are sometimes a lot of computation is required, so you should have a proper modest internet connection. Yeah, now it's showing. Here you can see it has 21,54,765 images. Yeah, I'm good at math. Now we can apply. So here is the thing, you can see we don't require all of the images for our processing. Suppose we need the images from for some span, okay, like for the 2000 year, for the images from the 2000, or from the images from 2001. So how it will reduce the size of images that we require, let's say. So here is the thing, you can see there is a command filter date, which will give the images from 2000 April, month April to the July. Okay, so now if I run the script, here you will see the image size will decrease. That means it is now the collection variable is now only contain the images from the April to the July of year 2000, right? So now our variable connection is contains 24,850 images. So if I go back to my original script, after here you can see there is another function filter bounds, which is defining region. Okay. After that, we are computing the median pixel composite of the median in each band of each pixel by this command, and then we are defining the bands of the images B3, B2, and B1, and then we are adding a layer by map.add_layer and creating a true color composite of the region. Here another function you can see map.set center centers the map view at a given coordinate with the given zoom level. Now before proceeding further, I want to give you a little background of the Google Earth engine. The Google Earth engine is made for scientists, researchers, developers who are not very intuitively good with the IT and software stuffs. Like Google Earth engine is solely made so that you don't have to be bothered about machine management, asset management, like lot of management stuffs to make everything easy for you to analysis. Basically, they removed all IT problems. Google Earth engine specifically built trying to focus on things like deforestation, climate change, droughts, etc. etc. Now, what Google Earth makes so easy that it has tons of data, all processed and ready to use, Landsat, Sentinel-1, 2, Moody's data, etc. Now, come to the coding section. When we use Google Earth Engine, it has couple of options: JavaScript API and Python API. JavaScript API is attached with interactive code development environment. It also has Python API, which is just a Python module download and install. But you probably think what to use, JavaScript or Python. If you want to use interactive code editor, just write some code and run, then use JavaScript because all things are written in function. Just take from documentation and see by yourself. But if you want to code in Python, with the Python API, you're going to have to make that by yourself. But if you use Jupyter Notebook, that will be easy, but still you have to go through some steps like importing modules and managing data, etc. So it's little easier just go in JavaScript API and write some code, but it's little bit of hasty to go in Jupyter Notebook and have all the right modules installed. So it is recommended to start with interactive code editor because it's the one with support and got inline documents. It's got inspector, it has fast interactive visualization. But translation from JavaScript to Python is trivial. If you think just to use Python module like pil, numpy and scipy etc. modules, it doesn't work like that. Like you build a computational description and you send the code to the server of Google Earth Engine, and server does not know anything about pil, numpy or scipy like Python modules, then it will not work. So it's not a trivial just to use arbitrary Python modules and trying to make it easy. If you are working with terabytes of data and taking terabytes of data into NumPy module and expect it to work, but there are always some limitation. So we will use the built-in code editor provided by Google Earth Engine. The two most fundamental geographic data structures in Earth Engine are image and features, corresponding to raster and vector data types respectively. So if I search like Landsat images, you will find the bands for the Landsat 7, and there are some image properties. Features are composed of geometry and dictionary of properties also. So features contains of lines, point, polygon and boxes and a list of properties. You can see these are boxes, polygons, lines, etc. Okay. And images are also that they have properties, they have bands, and they have all geometrics, as I shown. Images also have, in addition to geometry, a date, because we expect to be able to filter and sort them based on the date, as I shown you here. Okay. So there's two properties of geometry and date, and then you also have addition properties like features. Now the last data model is a collection, just like combination of things. So if you got some features and put them together into, for instance, a table, then that's the collection of features. Likewise, if you have a bunch of images and you put them on a directory, then we have a collection of images. A stack of images, like an image time series, is handled by the image collection. A collection of features is handled by the function name called feature collection. We can do filtering, joining, sorting on collections. So once we you have collected a bunch of things together, you can do all these things, including mapping and reduce. Other fundamental data structures in Earth Engine including directory, list, array, date, number, and string. I will put the link of the documentation so you can understand more about this thing in details. And these things are like starting up Google Earth Engine. So thank you everyone. We appreciate your time to watch the video. Do like the video and subscribe the channel for more content on remote sensing in upcoming lectures.